Hello everyone. In this video, I will be talking about the right hand grip rule. It is not by any means a difficult concept to learn, but to really understand it, we have to first talk about electromagnetism. Now we can clearly see that electromagnetism is made up of two words that we are very much familiar with. Those words are electricity and, of course, magnetism. We know what both are. Electricity is the movement of charges through a conductor. Of course, when that conductor is electrical wiring and therefore metal, those charges come from electrons. Magnetism is the property that describes forces of attraction or repulsion as experienced by bodies or objects in a magnetic field. All right. So with that said, what is the right hand grip rule? Well, simply put, several years ago, in fact, 200 years ago, scientists did not feel like electricity and magnetism were related concepts. In fact, it was left to a Dutch scientist, I think his name was Hans Christian, who, in attempting to convince his student that electricity had nothing to do with magnetism, proved the opposite. It's actually a very interesting story. I'm sure you would enjoy reading up on it. Anyways, the right hand grip rule is simple. It is a way for us to tell the direction that the current will be going in the conductor versus the direction that the magnetic field will be going. Here in this line diagram, the arrow is representing a straight conductor. Straight simply means there are no curves. The magnetic field is going to be indicated by the curved fingers when we pretend we're holding the straight conductor in such a way that the thumb points in the direction of the current. Let me say that part again. So your thumb is going to be pointing in the direction of the current, and where your fingers coil will represent the magnetic field. What's important for us to consider here is that we're talking about the right hand. If you should pretend you're gripping the conductor with your left hand, well, you're going to get the directions wrong. Let's go up to this image here. We have to talk about the applications of the right hand grip rule. Here we see a straight conductor once again, and this individual is holding his thumb in the direction of the current. Therefore, the thumb right here, draw an arrow, is representing the current, as we said earlier, whereas the coiled fingers are representing the direction of the magnetic field. All right, now this is the case for a straight conductor, but we also have to think about the right hand grip rule as applied to coils. Just write coils right here. In other words, solenoid. Now, a solenoid is simply a cylindrical base that has coils of wires around it, as we can see in the image. Whenever we're dealing with a solenoid, we have to modify the right-hand grip rule. In this case, we're going to hold or pretend we're holding the solenoid or the coil in such a way that our fingers that are coiled represent the direction of the current. Because our fingers now represent the current, our thumb will be pointing in the direction of, yep, the magnetic field. All right, so let me just kind of summarize what was going on right there. Spoken about the right hand grip rule. We know this is speaking about the direction of, it's kind of so, put it in arrows, direction of current versus the direction of the magnetic field. All right. And we know that it is going to be different based on if we're talking about a straight conductor, as in this case, versus the solenoid, as we're seeing here. So let's look at a Csec question that we have to apply our newly learned knowledge. Or I shouldn't say newly. I'm sure many of you already know this and you're just refreshing yourselves. But this question is taken from, I think it's 2018. All right, let me just go ahead and read it. It says the figure shows the magnetic field between the poles of a strong magnet. Of course, whenever we have magnets, bar magnets face each other in this way, the magnetic field lines or the flux is going to be uniform. Sometimes you will see it bulging at the edges, and this is just due to what we call repulsion from the other field lines that are next to it. You're kind of pushing it away. But that's what that is. Let's move to the actual question they're asking. They say complete the following diagrams to show, let me magnify that. Complete the following diagrams to show the magnetic field due to a current carrying conductor where the current is directed into the plane of the paper. All right, there's an important concept we have to learn for this. Whenever we're talking about the direction of the current, it can sometimes be annotated with two diagrams. One is a circle with a dot, and this represents the current coming towards us. All right, so that would be if the current in the conductor is moving towards us, it's coming towards us, versus if we have a circle with an X. And this simply means that the current is moving away from us. All right, so the X will represent the current going into the plane of the paper or into the device that you're looking at. It's moving away from you. Whereas the circle with the dot will represent the current moving towards you. So just looking at what they've given us here, this circle with the X, we know the direction of the current. It's coming where? It's coming, well, it's not coming towards us in this case. It is moving away from us. That's what the X represents. So what we have to do to determine the direction of the magnetic field is to go for our right hand grip rule. We take our right hand. This is for a straight carrying conductor because they didn't indicate differently. And we're going to place our thumb in the direction of the magnetic field. All right, because it's an X, it's moving away from us. So your thumb should be pointing towards the screen or towards the paper. The fingers of your hand curl, and you know that these curled fingers represent what? the direction of the magnetic field. And in what direction are your fingers curled? Well, that's fairly simple. We know that is going to be represented by concentric circles. Simply means circles around the X getting consecutively larger. Do forgive my lopsided circles, but I just want you to get the point. The only thing that is left is for us to indicate the direction, and we know it because we used our right hand grip rule. Will be that way. I'm simply having my arrows show it. Let me use it in a different ink. All right, so this covers the right hand grip rule. I hope you would have learned something, refreshed yourself on something. And if you have any other questions, you can direct them my way. I will try to help you as best as I possibly can. All right, all the best.